Let's see what are all the basics involved in the concepts of analog communication. What is a communication system? It is a branch of engineering that is dealing with the sending and receiving of signals by means of electrical, acoustic, or electromagnetic waves, or it is dealing with the development and operation of communication technology, including telecommunication and computer programming. Let's see in detail the block diagram of a communication system. A communication system involves an information source, which may be an audio, video, or any kind of information which you are going to send. The information source reaches the input transducer. A transducer is a device that is going to convert one form of energy to another. Then comes the transmitter, the channel, and the channel is always prone to noise, especially in case of wireless communication. The receiver consists of an output transducer and the output device. The information source generates the information. The transducer converts some form of energy into an electrical signal or electrical energy. The transmitter performs the modulation and the amplification process. The modulated signal is fed through the channel, which is a transmission medium. The noise from the external sources are prone in the channel. From the channel, the signal reaches the receiver, where the receiver performs the demodulation, filtering, and amplification process. The demodulated signal reaches the output transducer. There, the output transducer converts the electromagnetic energy into electrical energy and is fed to the output device, which may be a speaker, television, or PC based on the application. So, this is a general block diagram of a communication system. Let's see what is modulation and what is the need for modulation. Modulation is the process of varying the characteristics of the carrier in accordance with the instantaneous change in the characteristics of the message signal or the modulating signal. So usually the message signal is called the modulating signal. The three characteristics that can be varied for modulation will be amplitude, frequency, and phase. What is the need for modulation? Why you need to go for modulation? The first basic principle is the antenna size. We know the relation between the wavelength and the frequency. The lambda is equal to c by f, where c is the speed of light in free space, which is 3 into 10 to the power of 8 meters per second. To increase the communication range, we can go for modulation. Modulation process also supports the multiplexing of signals, and the bandwidth requirement is also benefited by the use of modulation. Let's see the types of modulation. Modulation is generally categorized as continuous wave modulation and pulse modulation. Under continuous wave modulation, we have amplitude modulation and angle modulation. Under pulse modulation, we have digital modulation and analog modulation. Angle modulation is further categorized into frequency modulation and phase modulation. So this amplitude modulation, frequency modulation, and phase modulation comes under continuous wave modulation. The analog pulse modulation comprises of PAM, PWM, and PPM. PAM is pulse amplitude modulation, PWM is pulse width modulation or pulse duration modulation, and PPM is pulse position modulation. And the digital modulation technique comprises of the PCM, delta modulation, ADM, DEM, ADPCM, and the multiplex keying techniques. Let's go into deeper about amplitude modulation. As the name suggests, the process of varying the carrier wave amplitude in accordance with the instantaneous change in the amplitude of the message signal is called as amplitude modulation. The mathematical representation of an amplitude modulated wave is given by m of t. M of t is a signal representation of am cos omega mt, where am represents the message amplitude and omega m represents the frequency of the modulating signal. And the carrier signal is represented by C of t, which is AC cos omega CT, where AC is the peak amplitude of the carrier signal and omega C is the angular frequency of the carrier signal, where FC is the carrier frequency. So according to the definition of modulation, we change the amplitude of the carrier. So the AM signal is represented by AC plus M of t into cos omega CT. M of t is the message signal. Substituting for M of t as AM cos omega mt, we get the output equation for the amplitude modulated wave. The mathematical representation of an AM wave. So by rearranging the AM signal equation, we get AC cos omega CT plus 1 by 2 into 2 AM cos omega mt into cos omega CT. Applying the trigonometric principles, we are categorizing the final equation of an AM wave as carrier wave, upper sideband and lower sideband terms. Here, the term MA represents the modulation index. The modulation index is given by AM by AC. And the total bandwidth from this calculation of an AM is twice of bandwidth. The frequency spectrum of an AM wave consists of the lower sideband and the upper sideband. The frequency spectrum of an AM wave can be analyzed using a spectrum analyzer, where the power spectrum of the signal can be fed through the spectrum analyzer. So the spectrum of an AM wave extends from Fc minus Fm to Fc plus Fm from the lower sideband to the upper sideband frequencies. Now let's see what is modulation index. It is defined as the ratio between the amplitude of the message signal to the amplitude of the carrier signal. So usually the modulation index is represented by MA or beta, which is AM by AC or EM by EC. So the modulation index multiplied by 100 is known as the percentage modulation, that is AM by AC into 100. For 100% perfect modulation, the modulation index should be always 1 or unity. So based on the modulation index, we are going to categorize the degrees of modulation as under modulation, where your modulation index is less than 1. Critical modulation or 100% modulation, where a modulation index is equal to 1. Over modulation, where the modulation index is greater than 1. So based on the modulation index, the generated AM wave can be differentiated from the waveform. So modulation index in terms of voltages. So in terms of voltages, the modulation index is represented by maximum voltage minus minimum voltage divided by maximum voltage plus minimum voltage. So the maximum voltage of the output AM wave is given by Vmax and the minimum voltage is given by V minimum. So those upper and lower voltage levels are represented as crest and trough. So the V minimum is given by Vc minus Vm. We know that Vc is the voltage of the carrier and Vm is the voltage of the modulating signal. And Vmax, that is the crest, is given by Vc plus Vm. So substituting for Vc and Vm, we can get Vc is equal to Vmax plus V minimum divided by 2 and Vm is Vmax minus V minimum by 2. So hence the modulation index Vm by Vc is equal to Vmax minus V minimum divided by Vmax plus V minimum. Let's see the power distribution in AM. So in radio transmission, the AM signal is generally amplified by a power amplifier and fed to the antenna with an ideal characteristic impedance but pure resistance value. The AM signal is a composite of several signal voltages. That is, it has the carrier, it has the sidebands, that is the upper sideband and the lower sideband. So the power transmitted, the total power transmitted is the sum of the carrier power plus the upper sideband power and the lower sideband power. So the carrier power is given by PC and the power of the upper sideband is given by PUSB and the power of the lower sideband is given by PLSB. So in general, considering the equation for the power of the carrier, that is V square by R, we can write VC by root 2 the whole square divided by R, where the antenna radiation distance is represented by R. So the power of the carrier is Vc square divided by 2R. And each sideband value is represented by M into Vc by 2, whereas M represents the modulation index. And the RMS value is MVC divided by 2 root 2. So the power of the upper sideband and the lower sideband is calculated to be M square by 4 into power of the carrier. So adding all the three powers, that is the power of the carrier, power of the upper sideband and the power of the lower sideband, we get the total power transmitted by the AM wave, which is Pt is equal to Vc square divided by 2R plus M square by 4 into Pc plus M square by 4 into Pc, where this first term represents the power of the carrier, the next two terms represents the power of the upper sideband and the lower sideband. So consolidating, I may get the power transmitted to be Pc into 1 plus M square divided by 2. So if the current value is RMS values of the unmodulated current and the total current of the carrier is given by IT and IC, so then the resistance change to IT square by R into IC square divided by R. So and from which the power efficiency can be calculated, power sideband divided by the power of the carrier. So under critical modulation condition, the substituting M equal to 1, the power of this conventional AM or the double sideband full carrier AM is 0.33 or 33%. So thus we end up the session of amplitude modulation by looking on to the advantages, disadvantages and applications of double sideband full carrier. So it is a traditional conventional AM. So advantages are it is simple, receivers are used narrow bandwidth than FM, wide coverage and used for broadcasting purpose. And the disadvantages can be seen as the interference. The DSP-SC is more prone to interference. So the receivers are able to produce only frequencies up to 5 megahertz or less. That is lesser transmission frequency. So most of the transmitted power is wasted. And the major application is two-way radio communication and is used for broadcasting and aircraft communication. So thus we have seen about the basic concepts of modulation and what is amplitude modulation and how the power is calculated for an AM wave and advantages, disadvantages and applications of AM. In the next session, we shall see about FM. Thank you.